So we are discussing the fundamentals of conic sections. Conic sections, you have a cone. You know what cone is? You know, you might have eaten the ice cream. So this is an inverted ice cream cone, or the hat you wear in on your birthdays when you were a kid. So a cone, the sections of a cone, if you cut from here, if you pass a plane from which is parallel to the base, you'll get a circle. If it is transverse or somewhat inclined, we'll get a ellipse. If you make it transverse or oblique and you pass the plane outside the boundary, then you find a parabola. And once you make it straight or perpendicular to the circular base, it is a hyperbola. So what we are going to see is uh, you'll be able to identify the standard form of equation for the circle, ellipses, parabolas and hyperbolas. You may be able to write the equations and to determine the center, radius, the focus and foci, directrix, the asymptotes for the conic sections. And you will be able to identify the eccentricity also. So let us start with the circle. Circle, an intersection of a plane with a three-dimensional figure is a circle. What about the conic section? An intersection of a plane with a cone. And the circle, the set of points that are at a fixed distance from, say, called a radius, from a fixed point called the center. So the locus of a point which are equidistant from a point or a point which is called the center. This locus of the point is the circle. Radius is this distance from the center of a circle or a sphere to the edge. These are all conic sections. This is circle, this is ellipse, this is parabola, this is hyperbola. There are other views of conic section also. See, the parabola, which is cutting plane parallel to the side of the cone. A plane which is cutting the cone placed parallel to the side of the cone. And the circle and ellipse, of course, by oblique plane and a straight plane, which is parallel to the base. The hyperbola, the plane which is parallel to the axis of the cone. This is a circle. This is a circle. So equation of a circle is given by x square plus y square is equal to r square if the center is at 0, 0. That is the origin. So you can determine the equation of a circle by using the distance formula, which is applying the standard form equation. You can use the standard form. So most of the time we assume that here center is 0, 0. So otherwise it will be stated. If you have center at say hk, then it will be x minus h whole square plus y minus k whole square is equal to the radius square. H and k are the center, means the point from where you are finding out the distances, that is the radius. And what is this h and k? If you place it 0, 0, it will be x square plus y square is equal to r square. That means this is the standard form. You see here. What about the ellipse? Ellipse, a set of points in a plane such that the sum of the distance from two foci to any point on the ellipse is constant. The focus, if you want to say two focus, it will become foci. So foci is the plural of focus. So these are one or two fixed points within say an ellipse such that the sum of the distances from the points to any other point in the ellipses, it will remain constant. For example, ellipse look like this. This we call as a major axis, this we call as a minor axis. This is hk, that is the center of the ellipse. This is y-axis, x-axis, with this h and k center, that is okay. And this a and b, a is the semi-major axis, 2a is the whole axis, while 2b is the minor axis. If a and b are equal, this ellipse will become a circle. What we are trying to say is that these are two focus, f1 and f2. So the sum of the distance from one focus, if it is x, and this is y, this distance is y, this distance is x. So x plus y will remain constant. Even if you take distance like this. If you sum, say it is I, this is j. So I plus j will be equal to x plus y. This is what we are trying to say. If you place it on a scale also, it is going to give you the constant of any point with respect to the focus. So in ellipses, you have vertices. For ellipse, x and y intercepts are the vertices, x and y intercepts. The major axis for an ellipse, the longer axis of the symmetry, as I just shown you, the axis that contains the foci. And minor axis for an ellipse, the shorter axis of the symmetry, and this minor axis will not contain the foci. The center of an ellipse is the intersection of the major axis and the minor axis. This is the equation of an ellipse. This is given by x square by 2 square plus y square by 1 square is equal to 1. And what is this 2 and 1? 2 and in 1 is nothing but x square by a square plus y square by b square. Let us take a general form. X square plus a square plus y square by b square is equal to 1. A and b. A is the semi-major axis. How much is this from 0, 0? This is 2. This distance is 2. This distance is 2. So x square by a square. So x square by 2 square. What is this distance? What is the distance? This is 1. This is 1. So y square by 1 square. That is b we have taken as 1. So x square by a square plus y square by b square is equal to 1. This is the equation for an ellipse. Let us again talk about the parts of an ellipse. Revisit them. First, this is the center of the ellipse. These are two focus. These are the vertex of the ellipse. This is the major axis. This is the minor axis. And these two are the co-vertex. And just take an example of real life. You can see that the sun and the earth or any planet which revolves around a sun, it revolves in an elliptical orbit. This is what is said by the this is the Kepler's law, first law of Kepler, I presume. So Kepler law says, and we'll see that the planet, wherever it moves, the distance from two foci, this you add this one, this distance with this distance, this will always remain constant. Either you take any of the point. These are the focus. One focus is the sun. Your planet is moving or revolving in the elliptical orbit. Here we call it as aphelion. Here we call it, when it is closer to sun, we call it is at perihelion. This is the semi-major axis. This is the semi-minor axis. So as we just told you that you have a central angle. In this you have a minor arc also, major arc. And why we are talking about this? Because ultimately ellipse, when the semi-major and semi-minor axis they become equal, the ellipse becomes a circle. Let us come to the hyperbolas. So hyperbola, a set of points such that the difference of the distance from two fixed points to any point on the hyperbola is constant. Now this definition is an inversion of, or we can say opposite of the ellipse. So hyperbola and ellipse, they have opposite or inverted definitions. So vertices, x and y intercepts of a hyperbola, they are vertices. Asymptote, the straight line that a curve approaches but never reaches. These are asymptote. How does hyperbola look like? The formula first let me tell you. This is x square by a square. If you can see here, x square by a square minus y square by b square is equal to 1. This is the equation of the hyperbola. And first focus is this one. Second focus is this one. This is the axis of the hyperbola. And what we are trying to say is, any distance you take from this, the difference of these values, this one and this one take difference, or this one and this one take difference, they will be equal. So y is equal to b minus b by a. This is the equation of this line, and y is equal to b by ax is the equation of this line. These are the asymptotes which you see in red. They approach this hyperbola, but they are never going to touch it. So these are the asymptotes, the horizontal asymptote, the vertical asymptote. Okay, so we have two asymptotes. Now let us come to the parabola. What is the parabola? Parabola is a set of points in a plane that are equidistant from focus and a fixed line. Let me tell you, a parabola is a set of points, is a locus of a point, set of points in a plane that are equidistant from a focus and a fixed line. The directrix. In parabola, we have a concept of directrix. What is this directrix? The fixed straight line that together with the point known as the focus serve us to define a parabola. So now in this case, as you see, this is a parabola for us, and this is the directrix. Okay, now if parabola is vertex A, the focus on the right side is at a distance A, and the directrix is at a point of or at a distance of A. Both these distances should be equal. Here, directrix, as you can see, it is y-axis actually. So it will give x is equal to minus a, because this is minus a from 0, 0. This is the directrix. So a distance from a point which is a focus, and the distance of the point from the directrix, if you add them, or any point you add them, this plus this are same. So let me give you an example. This is A, this is B. This distance is A, this is B. This distance is say P, this distance is Q. So A plus B will be equal to P plus Q. This is the locus of the definition of the this parabola. And now what I want to tell you here is we have one focus only. We don't have two focuses. What about the eccentricity? So eccentricity is the ratio of distance from the focus and the distance from the directrix. And each shape has its own eccentricity, whether it be circle, parabola, hyperbola, or ellipse. They all have the eccentricity. For circle, we have eccentricity is equal to 0, because the ratio of the distance from the focus and the distance from the directrix. Circle gives it to be 0. For ellipse, E lies between 0 and 1. For parabola, it is E is equal to 1, E is equal to 1. For hyperbola, E is greater than 1. So, this parabola, we have other version also. This is a parabola. See? This is again a parabola with different eccentricity. The eccentricity of this parabola, where we have eccentricity equal to infinite. This is your directrix. This is your focus. And the ellipse for eccentricity, it is given as 0.5. Parabola, hyperbola, and eccentricity, they all have, parabola, hyperbola, and ellipse, they all have certain eccentricity. For ellipse, what is the eccentricity? We have just seen. Please answer this. So in the real life, the eccentricity, see, 0.96. How we got this? I leave you with this exercise. This is a real life parabola. We have parabolas in transmission. The antennas are made like this to gather more incoming radiations, and they can be directed. So this can be taken. See, this McDonald's also is showing some parabolas. This is a hyperbola. Again a hyperbola. So we knew now that what are the conic sections.